We're going to begin discussing various methods of factoring polynomials, and we can view factoring as the reverse process of multiplication. For instance, a simple example, let's imagine if we had like 2 times x plus 6, and we're asked to multiply this. Not necessarily another polynomial, but we distributed something with variables before also. Well, we would send this through and multiply this by both terms. That would give me 2 times x plus 2 times 6. Okay, and I would multiply each of these, so the result would be 2x plus 12. And we stopped there before. But what we want to do now is the reverse process of this. We want to start with something like 2x plus 12 and get back to this kind of thing where we have multiple terms, maybe in parentheses, multiplied. That's what we mean by factors, things multiplied together. So instead of distributing into parentheses, we'll be given some expression and we want to divide out some common terms, things that we can divide, like things that they have in common. So this first method of factoring is called GCF, which stands for greatest common factor. Common factor. So what do they have in common? That this is the case when every term can be divided by some common number, or they share some common number of exponents, and those are or some common number of variables, and those are the two things that I'm looking for. So for instance, number 9, we're like at where we left off here. If I'm looking at this fresh, okay, 2x plus 12, I'm thinking, what can I divide out of this, or what do they have in common? I'll look first at the numbers, so 2 and 12. They're both divisible by 2. In fact, that's the only thing I can divide them both by. So our greatest common factor would include the 2, and this term has an x, and this term doesn't have an x, so they don't have any variables in common. So this is what they have in common altogether, our greatest common factor. So we're doing this like reverse distribution. That means I would write a 2 out in front, and then I think about what's left over after dividing out this 2. Like in my first term, 2 divided by 2 is 1, and then I should still have that x left over. The second one, 12 divided by 2 is 6. So the result should be 2 times x plus 6. Which is like where we started with that initial example. So we're reversing the process of distribution in doing this greatest common factor factoring. So let's look at number 11. This time they both have variables. X to the 5th plus 9x to the 4th. What do they have in common? What can we extract out? This is technically a 1 in front, so 1 and 9, they don't share any common factors besides 1. Can't divide anything else out. But this has 5 x's and this has 4 x's. So I'm thinking, what's the least amount that they both share? They both have at least 4 x's. So my greatest common factor in this case would be x to the 4th power. So that's what would show up in front of the parentheses, and I'll think about what's left over. In this first one, I'm taking out 4 x's. There should just be 1 left over, so x to the 1st power. In the second case, I took out all 4. There should be this 9 left over, plus 9. So x to the 4th times x plus 9. So reverse distribution. And we can always check ourselves with these by redistributing and see if you get the initial thing back, like 2x plus 12, or x to the 5th plus 9x to the 4th power. You can always throw it back in and see if you get our initial problem back. So let's look at number 12. They both have multiple things going on. Let's try to determine the greatest common factor. So I see 6 and 2. They're both divisible by 2. And then this one has 5y's and this one has 2y's. Y to the 5th and y squared. So they both have at least 2. So that means all I can take out is y squared. I can only take out like the lowest number that they have in common. I couldn't take more than 2 out because there's only 2 here. So we're trying to think, what can we extract out? So the 2y squared should be in front. And then 6 divided by 2 is 3. We took 2 y's out. We had 5 originally, so there should be 3 left over. 3y cubed And then notice we took like this entire term out. We took the 2 out and we took y squared out. So what should go left? Should I put 0 here? I still need to, if I were to multiply this back in, get our original thing back. So in a sense, we've divided this term by itself. I should just have a plus 1. It's kind of like a placeholder. But if I multiply this back in, I'll get 6y to the 5th, and then 2y squared times 1 gives us the 2y squared. If I didn't have this term, we wouldn't get our second term in multiplying this back out. So in this case, we could take a 2 out and 2 y's. It had both a number and some number of variables in common. And this works for more than 2 terms, as long as they all have something in common. So 14 has 35x to the 5th minus 25x squared plus 40x. So I'll go through again, think, what do they have in common? What is the greatest common factor? So 35, 25, and 40. They're all divisible by 5. I can divide them all by 5. And this has 5 x's, this has 2 x's, and this has 1 x, x to the first power. So I can take at least 1 out. I can't take any more than that. I should say I can take at most 1. So greatest common factor is 5x. So if that's brought out in front, what's left over? So let's take it one term at a time. 35 divided by 5 is 7. And I had 5 x's and I took 1 out, so there should be 4 left over. 7x to the 4th power. And then minus, because my minus here, 25 divided by 5 is 5. I had 2 x's, I took 1 out, there should be 1 left. And then 40 divided by 5 is 8. And I took that x out, there's no x's left over. So just the 8. So 5x times 7x to the 4th minus 5x plus 8. So we can have as many terms as we'd like, as long as they all have some common factor. We can bring that out in front, this reverse distribution. 17 is interesting, but it's something that we'll run into when we're factoring by grouping. It seems that we should at first distribute the y and the 8 and multiply this out to see what we have. But notice what's before us here. We have 9 times x minus 3 plus 8 times x minus 3. They're both multiplied by this common factor. I can view the parentheses as like one object. So without multiplying this out, I could just say that the greatest common factor is this x minus 3 in parentheses. So that means we can bring that out in front. Just like here, we're like bringing this 2 out in front. I think about what's left over. Common factor here is x minus 3. So that can come out in front. And then what's left over is just these, we can call them the coefficients here, the things that are multiplied in front. So y plus 8. This is kind of a tricky move. But it's the same, essentially the same idea as dividing out a 2. We're dividing out this common factor. We can even imagine multiplying it back through. X minus 3 would multiply first and attach to the y, and then it would multiply second and then attach to the 8. Although we would more likely maybe FOIL this, but we can imagine like distributing this whole set of parentheses. Kind of strange to imagine. But this is an allowable move. If we have like a set of parentheses that are the same, we can consider them a common factor. So all of this so far has been greatest common factor factoring, pulling some common factor out in front. Our next type of factoring is factoring by grouping, and this works when we have 4 terms. Notice there's 4 terms here. So that's a case where we might factor by grouping. So what's the process? We'll first put these into 2 groups of 2. So this is partially why it's called factoring by grouping. I'm going to put these into 2 sets of parentheses with a plus in between. So 20x minus 8. So placing them into 2 groups, I'll then think of any common factors between these 2 sets of parentheses. Or I'll do like greatest common factoring for each of these separately. Like in the first case, okay, 25 and minus 10. they both have, let's think of the greatest common factor just for this one. They're both divisible by 5, and they both have at least 2 x's. So 5x squared. And then for our second set, we have 20 and minus 8. They're both divisible by 4, and only one of them has a variable, so that's as much as we can take out from that one. So we place them in 2 sets of parentheses. Let's now factor as much as we can out of each of these 2 sets of parentheses. We said the greatest common factor here was 5x. So I'll think, what's left over? 25 divided by 5 is 5, and I had 3 x's. I took 1 out, so there's 2 left over. Then I should still have a minus here. 10 divided by 5 is 2. And, oh, let me come back here. I actually made a small mistake here. So I said 5x. What I really wanted to take out was 5x squared. So the 5 still reduced this down to 5, and then I took out 2 x's, so I should only have 1 left over. Okay, made a small mistake there. So in the second case, negative 10 divided by 5 is negative 2. And then we took 2 x's out, so there's none left over. So 5x minus 2. Now let's take out this 4 from our second set of parentheses. So that will come out in front. 20 divided by 4 is 5. Should still have an x there. And then negative 8 divided by 4 is negative 2. So we kind of had like 2 separate greatest common factor problems here. I brought out as much as I could from each of these. And then notice we now have this common set of parentheses, kind of like number 17. So this should happen if factoring by grouping is going as it should. You should end up at this point where we have a common set of parentheses with the same stuff inside. So let's take that as the greatest common factor of this expression and bring it out in front. And then what's left over will be these 2 coefficients. These will come in here. So I should have 5x squared plus 4. So it takes a little while to get used to, especially that last step of bring the common factor out in front. But this is specifically when we have 4 terms. So we have 4 terms here. It doesn't always work out, but we'll be given problems typically that can be factored. The first step is to place in 2 sets of parentheses, then pull out the greatest common factor from each of those, and you should be left with a copy of the same set of parentheses. In this case, it was 5x minus 2 and 5x minus 2. So after bringing out greatest common factor, we get a shared copy of parentheses. That can come out in front, and then the second factor are these 2 coefficients. Okay, so it's worth going through a few times with a few different variations of these to get a hold of that process, but it's kind of an extension of greatest common GCF factoring. Let's look at a technique for factoring a special kind of trinomial. So by trinomial, we mean a polynomial that has 3 terms, and specifically one that's to the 2nd power. We can also call this a quadratic. So a standard quadratic. So the a, b, and c just are placeholders for some numbers that we'll see, but terms that have, or expressions that have an x to a 2nd power, an x to the 1st power, and then some term without a variable, like x squared plus 9x plus 20. So we want to factor this, meaning we want to try to get this into some form where we have 2 sets of parentheses multiplied together. Let's go back to that and recall like how we would multiply such a thing out. X plus 4 times x plus 5. We did this before with foiling multiplication, where we multiply the first outer and inner and last. So first would be x times x. That gives me an x squared. Then my outer would be x times 5, so plus 5x. Then inner would be 4 times x, so plus 4x. Then the last is 5 times 4, so plus 20. And then we have some common terms to combine here. So x squared, this will be plus 9x plus 20. So our goal with factoring is to start here and come back to this starting point. We want to try to reverse this multiplication process. Notice this is our starting point here. So our end result should be x plus 4 times x plus 5. So we need a method for it to, how do we get from here to there? So I have the example here. Let's also write a method out. Let's try to set a series of steps. So the first thing that I'll do is check that I have this specific condition. So right now we're only looking at forms of this kind of quadratic expression where this a term, so this thing in front of the squared term, is equal to 1, meaning I don't see a number in front. There's like an implied positive 1 there. I'll say the first method is just to check that that's true. I'm going to say check that a is equal to 1. Otherwise, I'll need to use an alternative method. The other thing that I'll check for is if there's a greatest common factor. So this is more so for when we're going to be factoring more advanced things. But the first thing I usually check if I'm factoring, if there's some common factor I can bring out of all of my terms. They don't all have a variable, and then I have 1, 9, and 20. They don't all share a common number, so there's no greatest common factors. So we already meet both of those. And I'll make a note, okay, my a term is equal to 1, my b term is 9, my c term is 20. So if this is the case, that a is equal to 1, the next step in this process is to look at these two numbers, my c term and my b term. What I need to find are two numbers that when I multiply them, I get this c term, 20. So like two factors that when I multiply them, I get 20. But when I add them together, I get this middle term, this b term. It's kind of like a little puzzle, like a little riddle. What two numbers do I multiply to get the last term that when I add them together, I get this middle term? And I'm looking specifically just at the number in front of my variable, in front of x. So let me write that out more explicitly here. I'm trying to find factors of my c term. So factors of whatever that c value is, that sum, that add up, I'll say that sum to whatever the b term is. Factors of my c term that add up to my b term. And this might take some guessing and checking. I have to think, what can I multiply to get positive 20? That when I add, I get 9. I can just kind of go down the line, like 1 and 20. That's true that when I multiply them, I get 20, but when I add them, I get 21. So not that one. I know 20 is divisible by 2, so 2 and 10. That works for the multiplication, but when I add them, I get 12, which is not 9, so not that one. I can keep trying. I know 20 is divisible by 4. 4 times 5 is 20. And notice when I add them, I get positive 9. So these are the numbers that we want. It's not our solution yet, but those are the two numbers that we're looking for. In this case, positive 4 and 5. So again, that was two factors of the c term, numbers that multiply to equal our c term, that when I add them together, I get the b term. Once I find these two, notice these are our 4 and 5 here, I can just jump to building these two factors. This factors into x plus 4 and x plus 5. So you can jump straight to building two factors with your variable as the first position, and then these two numbers as our second positions. And then you can always check by multiplying this back out, which is essentially what we did here. You have to FOIL it. X squared plus 5x plus 4x, that gives us our 9x, and then plus 20. So I'll say the third step is just to build our two factors using those numbers. I'll just say it with the numbers from number 2. from step 2. So I checked first that I do have this special condition that there's no number in front of my squared term. Then I found 2 numbers that multiply to my third term that add up to my middle term. In that case, might take some guessing and checking, but we found the numbers 4 and 5. Then I can jump straight to building my 2 factors with my variable to the first power, and then I'll place this number here and this number here. Sometimes when this is like a negative number, it can be tricky because it means one of your numbers needs to be negative. But if this was like a -5, a -5, it would show up as a -5 here. So this process takes some time to get used to, and as you do a lot of these, you'll start to remember some common factors. This kind of forces us to get good at some of our division and times tables. But again, this is specifically factoring a quadratic trinomial with our a term equal to 1. Let's look now at a method for factoring a quadratic trinomial, this time with an a value greater than 1. So that means that there's some number in front of our x squared term, or a term with our variable to the second power. So we can't do that, our previous method where we just find factors of our third term that add up to our middle term. First off, we couldn't even find that, factors of 3 that add up to 14. There's no way we could find those. So we need some other kind of method. But the ultimate goal is still to get to translate this into 2 things multiplying, 2 factors with a variable in the first position and some numbers in our second position. Okay, so the method that I'm going to share here is called the AC method. There are other methods for factoring this sort of thing. I've seen like an X method or a method with a box. I'm going to share this particular method, AC method, that I've gotten a lot of use out of. It's called the AC method. Well, maybe let's first denote what our A, B, and C terms are in our ax squared plus bx plus c. I would call my A term this 8. So that's why we're in this condition, or A term is greater than 1. My B term is that 14, and C is 3. So our first step, we're factoring something like ax squared plus bx plus c. A value is greater than 1. I suppose we should first see that we're in this condition, which we are. But I'll say officially our first step will be to multiply the A and the C terms together. So we'll say multiply A times C. Why it's called the AC method. So for me over here, step 1, I'm going to do A times C is 8 times 3. So that's positive 24. Okay, so we multiplied 8 times C. Now it's this number that will find the 2 factors that add up to our middle term. So I want to say part 2. So kind of like our previous factoring method, let's find factors of this number we just created. I'll just say factors of A times C that sum to the B term. That sum to B. So let's say step 2. I'm finding factors of this number 24 that add up to my B term, which is 14. So 2 numbers that I multiply to get 24 that add up to 14. What are factors of 24? Like 1 and 24, 2 and 12. So again, it might take a little bit of guessing and checking, but 2 times 12 is 24, 2 plus 12 is 14. You could have used 4 and 6, but that would have added up to 10. So these are the 2 numbers that we need. In this case, we can't jump straight to building those 2 factors. Our third step, we're going to rewrite the middle term using the 2 numbers that we just produced in our last step. So rewrite this b term. So by rewrite the middle term, I'll say we're at step 3 here now. I'm going to rewrite our original expression, and then instead of saying 14x, I'll say that's 12x plus 2x. I'm splitting up that middle term. So I have 8x squared. Instead of 14x, I'll say plus 2x plus 12x plus 3. So I rewrote this middle term, this b term, using the two numbers from our previous step. So I split this up. Now we have 4 terms. It looks like we're making it more complicated, but the reason for doing this is now we have 4 terms that we can factor by grouping. So I'll say step 4. From here on out, let's just treat it like a factoring by grouping kind of question. So let's review that process. Factoring by grouping, I'll first put these into 2 sets of parentheses. So 2 sets of parentheses, and now, so let me write this as 8x squared plus 2x plus 12x plus 3. Sorry, got a little scattered with the color scheme here. But first step is to set it in 2 sets of parentheses. Now we find the greatest common factor of each of these sets of parentheses and factor out as much as we can. So in the first case, 8x squared plus 2x, they're both divisible by 2, and they both have an x in common. So if I factor out 2x, 8 divided by 2 is 4. I took 1x out, there should be 1 left. And then we took this whole 2x out, so I'll just put a plus 1 placeholder, dividing it by itself. And I can double check, that would give me 8x squared plus 2x. In the second case, they're both divisible by 3. I think that's as much as we can pull out. So 12 divided by 3 is 4. There should still be that x left over. 3 divided by 3 is 1. So then here's that kind of weird step. We have the common factor of 4x plus 1. That can come out in front. 4x plus 1. And then the result, the second factor are these 2 coefficients, 2x plus 3. So we should get 4x plus 1 times 2x plus 3. So let's review the process again, because it's a little bit complex. The first thing is noticing that we're in this condition in the first place. I have some quadratic expression, ax squared plus bx plus c, where the a term is greater than 1. We have some value there. In this case, it was a positive 8. So I start out by multiplying a times c for the AC method. I produce this number, and then now I find the factors of this number, a times c, 2 numbers that multiply to this number, that add up to the middle term, b, which was 14. So for us, that was 2 and 12, 2 numbers that multiply to this number that add up to our b term. Then I rewrote this middle term. I split up the 14x using these 2 numbers. So 8x squared came down. The 14x became 2x plus 12x. And brought down the plus 3. And then from that point on, we have 4 terms, so we can factor by grouping. So we put in 2 sets of parentheses. Factored out the greatest common factor, achieving this repeated set of parentheses. And then that repeated set comes out in front. And what's left over are the 2 coefficients. And if we need to check it, we can multiply this out. You can FOIL it and see, do I get the original expression back? So this is the AC method. I'll say again, there's other kinds of methods, like something called the X method or a box method. You arrive at the same result, so it gets you to the same place, but just different styles.